Imagine pulling off the impossible. You've just synthesized a brilliant new material in your workshop, but before you can write down the exact recipe, you pass away. In an instant, that breakthrough vanishes from human history. For centuries, this threat restricted early science. The brightest minds were limited by poor memory and unorganized notes. Early scientific progress remained hostage to human mortality. Knowledge did exist, but it was scattered across isolated regions and heavily fragmented. When scholars actually did write things down, the records were often unhelpful. Looking at this early manuscript, facts are heavily mixed with cryptic Greek symbols and mythological imagery like this Ouroboros. Early chemistry shared more visual DNA with magic than with data. This reliance on vague myths and word-of-mouth instructions created a historical trap. Every new generation was forced to repeat the same mistakes. They had to start from scratch, rediscovering the facts their ancestors had already confirmed. For centuries, brilliant thinkers spent their lives spinning their wheels, unable to build upon what came before. Advancement required a standardized protocol for remembering experiments as much as the discoveries themselves. Jabir ibn Hayyan believed that science required rigid, organized systems, not just random observations. He shifted the focus of the laboratory. He moved away from simply performing chemical reactions and placed the priority on meticulously recording them. Jabir developed a methodology for hundreds of materials, categorizing them by physical appearance, properties, and preparation methods. This standard structure allowed scientists to compare substances side by side. The organized view revealed hidden similarities and mathematical patterns invisible in old chaotic texts. When Jabir finished his work, he left behind highly structured templates for others to study, rather than a loose collection of cryptic recipes. This classification system transformed chemistry from isolated observations into an organized body of knowledge. The most immediate consequence of Jabir's standard structure was practical. A stranger could finally pick up his notes and understand them. Clear documentation enabled reproducibility, the ability to repeat a prior experiment and verify if the exact same results appear. This established a core tenet of modern science. A discovery holds zero value if someone else cannot verify it. Jabir made careful documentation scientifically equal in importance to the physical experiment itself. Over time, Jabir's writings evolved from personal lab notes into foundational reference guides that spread across the Islamic world and Europe. For the first time, scientific knowledge was freed from the fragile memory of the individual scientist. Looking at this 19th century engraving, you see the eventual explosion of shared, organized sciences. This was possible because education began to compound. Students no longer had to start from absolute zero. Researchers could build upward upon existing data, rather than repeating the work of the past. This transgenerational sharing formally established chemistry as a disciplined, forward-moving field of study. In modern terms, Jabir built the first analog scientific database 12 centuries before the first computer. His philosophy relied on three pillars that still govern science: collect accurate information, organize it logically, and make it available for others. You see that lineage in this modern lab notebook. The physical tools have changed, but every contemporary log relies on the framework Jabir championed. Jabir ibn Hayyan provided the architecture for scientific memory, ensuring human ideas survive, grow, and compound across centuries.